So guys, now we will see how the image is formed in eyes. See, there will be different phenomena when the image is far from the eye. Sorry, object is far from the eye, then phenomena will be different. But when the object is near to the eye, then phenomena will be different. You know, the ciliary muscle will do the work for the lens. When the object is very far, so lights are coming parallel. The ray lights are coming parallel. So what will happen actually? So we require more focal length, right? So obviously, if we need more focal length, so our ciliary muscles will get relaxed, and the size of the lens will become thin. This lens in our eyes is not solid; it is a jelly-like thing, you know. So it is a convex lens and it is a jelly-like thing. So when the object is very far from our eyes, so it will become very thin. And it will become thin, so what will happen? The focal length of the lens increases, so muscle will get relaxed, and the thin lens, it will be having a more focus, so it will focus the image on the retina. Let's see how it will be actually. Let's say this is the lens like this. Okay, this is our eye retina like this. Okay, so when the object is far, object is very far here. Let's say object is here somewhere like this. Okay, so the lines are coming parallel to this, right? Okay, lines are coming parallel to this like this. So what will happen here? As the light goes, one light will go past from the center and will go undeviated. We know very well when the line passes through the optic center, that line will go undeviated here, right? So it will go undeviated. Now one line which is parallel to this axis, now it will become the principal axis for the eyes. So this particular ray will focus on the retina like this. Okay, thanks. And we will get a sharp image here. We will get sharp image here. One thing you have to see here, when we talk about the convex lens, we know that whenever the parallel lines are coming, if they go through the lens, they will get diverted, they will get reflected to the focus. Yes or no, guys? So it means at this particular point, at this particular time, when the object is very far from the eyes, this will become the focus of the lens. Focus of the lens, and you see, at this time, lens is thin. Why lens is thin? Because we don't need to adjust the focus. We do the focus at the retina like this, and the parallel lines are coming like this, and will diverge to the focus. So we no need to relax. So the lens will be thin. Sorry, the lens will be thin here. So no need a thick lens. What thick lens actually does? See, if we compare two lenses, like one lens is thin like this, and one lens is thick like this. If rays are coming like this, so for this one, for this particular thing, the focus will be somewhere here like this. Focus will be like this. But for this thick glass, focus will be here. Means focus will be near somewhere. Okay, this is the thick glass, this is thin. Okay, so when the object is far, so muscle will be relaxed. Muscle will be relaxed and the lens will be thin. Okay, focal length will be more. Focal length will be more here, right? Okay. Now let's talk about when the object is near. Object is near, right? And how the image will form. So let's make a diagram for the lens. This is eye retina like this. Okay. The image is near to the eye. image is here, like this. So guys, one line will go from center, so that line will go like this. Okay. This is the principal axis, like this. Then this line has to go parallel. One line has to go parallel, and it has to go at the retina. To get the sharp image, this line has to meet to this line. Means this line, let's say this ray 1, this is ray 2. These two line has to meet at this point. Then only we will get the sharp image, right? So now the image will be formed like this. Now one thing we should see here, we know very well whenever there is a light ray parallel to the convex lens, it passes through the focus. So it means the focus becomes at this point. The focus is now at this point. So initially the focus was here. When the object was far, the focus was here. But now when the object comes near, the focus comes near to the lens. See here, let's say if I say this one f2 and if I say this one as f1, so can I say clearly f1 is greater than f2? Yes. So it means when the object is near, so what will happen? When the object is near, lens will become thick. Okay. Focal length decreases. Focal length decreases. Okay. And muscle will be not relaxed. They will be strained. Muscle will be alert, or we can say strained. Okay, it means what muscle will try to do, they will try to push the lens like this. They will try to push the lens. What will happen then when they push the lens is the curvature of the lens will become more, right? So it means what happens is, so when the muscle pushes the lens, this outer part becomes thick. So now it has the ability to deviate the lines, right? See, initially how it is deviating? It is deviating at a larger distance, but now he has to deviate line like this. Means it is passing through nearly. See how it is passing here? It is passing like this, but now it has to pass like this. It means focus is coming near. Means it has to, if it is a thin lens like this, so it is a thin lens like this, so line will go like this slowly. It will not bend that much. But if it is thick lens, the line has to bend more. Here bending is less. Here bending is more. I hope this point is clear for you guys. This bending is more, this bending is less. It means if thicker the lens, the power of the lens will be more. We know that power of the lens is 1 upon f. So if the power of this lens is P1 and the power of this lens is P2, obviously we can say P2 is greater than P1. Why? Because the F2 is less than F1. See, this is F1, this is F2, this is F2. I hope this point is clear now. So what happens is when the object comes near, so focus gets shifted towards the lens. So focal length will become less and less and less. Okay. So and when it was at far, focal length will be more. It means there are two limits of the focal length. One will be maximum focus length, one will be less minimum focal length. We will see where there is the maximum and where is the minimum. I hope this point is clear for you guys. Okay. Now guys, we will see what is the nearest point for the eyes and what is the farthest point for the eyes. See, if you observe, if you take anything, if I take this marker Here I can see it very clearly, no problem. I can see if I come closer, if I take it closer. Now I think I'm getting some strain in my eyes. Now if I take even more closer, I am getting too much strain in my eyes. But one point will come, I cannot see this image clearly. So how it is happening? It means there is a limit of the eyes up to which it can see the image. Means when it is very near, when it is coming very near to our eyes, there is a limit up to which we can see the image. But after some time, what will happen? As you come take near or even more near, so what will happen? That image will get vanished. It will get blur. So let's see at what point, up to what point we can see the image. So write down the heading that near point. Okay, so near point we see here, or we can say it is least distance. See guys, what happens is, let's say it is our eye. If I make, if the image is, if the object is here, right? Okay, so the light is going like this and the focus will be like this. If the object is here, let's say here it is, so one line will go from the center like this. Okay, one line will go like this and it will come like this. So focus is here. Okay, the lens is thin right now. Lens is thin. Lens is thin right now. So focus we will get at this point. Let's say it is at 1. Now we will take the image closer. When we take the image closer here, so what happens is, the image gets, the lens gets thick. Why it gets too thick, I will tell you. So one line will go from here like this. Okay, and the line will go like this. And it will go like this. So notice here, the focus shifted from here to here. The position of the object is 1. Position here, let's say position 1, here position 2. So where the object is moving near, object is going near to the eyes. So don't you feel the focus from here to here? Object is focus shifted from here to here. It means focus shifting here. Okay, now there is a limit. One point will come, let's say the image comes very near. Let's say the image comes very near to the eyes. So how the image will form now? Actually, it will not be able to form the image. Why? Because now this line will go like this. So they will meet somewhere here like this. Somewhere here they will meet. So it means there is a problem. The image is formed behind the retina. So it is the image. When the image is forming behind the retina, then we cannot see the image. It means there is some limit up to which it can shift its focus. One point will come, it will not be able to shift the focus. The point at which the eye cannot shift the focus, that particular distance from the eye is called the nearest point. and for the normal eyes that particular distance is 25 centimeters. If you take the image, if you take an object even closer than the 25 centimeter, then image will get blurred and it will get strain in your eyes, because your eyes will try to shift the focus. The lens will try to get thicker and thicker and thicker. One point will come that our ciliary muscle will not be able to produce that much focus. So it means the focus will shift near to the lens, but there is a limit. Up to that point, after that point, the focus cannot be shifted. So it means we will get a blur image of the object. So there is a near point, and near point is 25 centimeters. I hope this point is clear for you guys. So near point is where this is 25 centimeters. I think this point is clear for you guys. So what happens is, whenever the object comes near, the lens becomes thicker and thicker and thicker. One point will come, the lens cannot become thicker than that, because there is a limit of ciliary muscle to contract the lens, right? I hope this point is clear. Let's see the far point. Let's see the far point. Okay. See, whenever there is a far point, so lens will become very thin. So if we know that whenever there is a light coming parallel to the principal axis, they will project at a focus. So we know that if we keep an object at infinity also, then the lines will become parallel. Lines will come parallel to the principal axis. Obviously they will get focus on the retina, like this. Okay, it means there is no far point for the human eyes, because obviously the lines get parallel. You can see the sun, you can see the stars. They are very, very far from our sight, but we can see them. Why? Because they are infinity, and the light rays coming from that are parallel, so that we can see them, right? So that's why we can say there is no far point. No far point. And we can say far point is at infinity. Okay guys, I hope this point is clear for all of you guys. Just let's see the field of view. Field of view. Field of view. Field of view. See guys, for a single eye, if this is a single eye, we can see like this. See, whenever I close my eyes, some part will be invisible, and some, see, it will be working normally. But as I close my this eyes, so I cannot see some part this side. So why it is so? Because combining with two eyes, we can see more thing. We can see like this. But with a single eye, we can see very less. So for this angle is 150 degrees. It means if anything comes in this field of view, we can see. If the object is here, we can see them. If object is here, so this object is visible. This is visible, and this is not visible. Okay? Now, but surprisingly, if we have two eyes, we can see like this. Like this. We can see. But for a single eye, we can see like this only. Up to this. Like this we can see. But if we have two eyes, we can see like that. It means what? If we have two eyes, like this, then field of view will be like this. And this angle is 180 degrees. Means we can see, if I keep the marker here, I can see the marker. See, what is the angle between here? See, 180 degrees. But I can see the marker from here. See, I think in mobile also they will see that IPS display and all this. They actually are telling you the angle, viewing angle. They are saying that view angle. See, if there is a phone, there is a mobile like this, we can see. If we see directly like this, we can see that. But if I see from an angle, this is a screen. This is actually, they want to tell you the field of view, right? They are telling you at what angle you can see the image clearly. Some angle will come, you will not be able to see the screen. Okay, so that is the view angle. Okay, now for this one, the field of view is 180 degree. Now whatever the things there in front of us, we can see that. But anything which is behind the 180 degrees, that will not be visible, not visible here. And it will be visible, rigid. I hope this point is clear for you guys. Just take this one fast. So guys, let's stop the lecture here. So in the next lecture we will see myopia and the sight. This is a like defect in sighting. Sometimes we can see the near things, but we cannot see the far things. We can see far things, but we cannot see near things. That we will see in the next lecture. Okay. So we'll stop the lecture here only. So keep studying, keep loving the lectures, and keep physics unboxing. Bye.